Jai Hind children, welcome back. Now we are going to study Venn diagrams. The relationship between sets can be represented by means of diagrams called Venn diagrams. Venn diagrams are named after the English logician John Venn. These diagrams consist of rectangles and closed curves, usually circles. The universal set is usually represented by the rectangle and its subsets by circles. The elements of the sets are written in their respective circles. Let us see what a Venn diagram is. Okay, now we can discuss about the Venn diagrams. Already told you that the universal set is represented by U and the circles are represented as the subsets of the universal set. For example, consider the set A or the universal set U, which consists of the elements 1, 2, 3, 4, etc. up to 10. And I am going to consider two sets. Let A be the set as 1, 2, 3 and B be the set as 4, 5. How to represent this universal set as well as the sets A and B in this Venn diagram? I told you that the universal set is represented in the rectangle and the set A equals 1, 2, 3 in which the set is represented with the circles and the elements are marked within the circles as 1, 2, 3 etc. like this. And set B consists of the elements 4 and 5. Now the remaining elements 6, 7, 8, 9 and 10 that you need to represent anywhere within this rectangle. So this is the way of representing sets by means of Venn diagrams. Venn diagram means the rectangle represents the universal set and all the subsets are marked with its elements within that in the circle. Through an example, I will give you the idea of how we can make operations on sets. Here clearly A is a subset of the universal set and B is also a subset of universal set. Now we are going to study about operations on sets. Operations on sets. Several operations are there. Before starting with operations on sets, let us see how we can make operations on numbers. Consider two numbers 3 and 8. If I use the operation plus, you will get 3 plus 8 equals 11, another number. If I use for the same element 3 and 8, if I use the operation into, you get another element 3 into 8 which is 24, which is another element. So, in the case of numbers, you know that when two numbers are being operated, you get another number. Same is the case of sets also. When two sets are being performed with some operation, then you get another set. We will now define certain operations on set. The first operation I am going to define as union of sets. Union of sets. Union of sets is usually represented with a symbol like this. Union. This universal set is actually U. This is a symbolic representation for union. Okay, through an example, we can see what an union is. Consider the set A equal to the set 2, 4, 6, 8. And another set B as the set 6, 8, 10 and 12. I will give the rule for to find the union of two sets. A union B. The rule is like this. You need to take all the elements of the set A and all the elements of the set B the condition is that the common element being taken only once. Common element being taken only once. only once. This is very important. The condition is very important. You can take all the elements of A and all the elements of B, but the common element being taken only once. This is the condition. For example, in the above set, we can define what is A union B. So, before writing what you want to do, we need to find out the common elements among the sets. I want to make the union of A and B, so the common elements among the sets are 6 and 8. So, what you want to do, you need to write all the elements of A. Which are the elements of A? 2, 4, 6, 8. And all the elements of B you can write, but the condition is that the common element being taken only once. Already the common element 6, 8 I wrote here. So only once only we can write. So the remaining elements in B are 10 and 12. So actually this is the union of A and B, A union B. So from this clearly we can say that A union B equals the elements are either in A or in B or in both the sets. Look at this. The elements are either in A, 2, 4, 6, 8. They are either in A or in B. The element 6, 8, and 12 are in B or in both. The 6 and 8 are common in both. So actually this is the way for writing union of two sets. Consider another example. Example 2. I am going to consider two sets. Let A equal to the set A, E, I, O, U. And another set B equal to the set A, I, U. I am going to show that if, the question is if, I am going to show that A union B equal to A. We can take A union B at first. Before taking A union B, what you want to do? You need to identify the common elements. A is common between these two sets. I is common between these two sets. And U is also common between these two sets. So the common element being writing only once. So A union B. At first I am going to write all the elements of A. A, E, I, O, U. But you can write the elements of B, but the common elements being repeated only once. The three elements are common, so I can't write anything further. All the three elements are already written. So this is the set A union B. Look at this. A, E, I, O, U is the original set A. So from this you can say that, which implies A union B equal to A. In this case, A union B equal to A. So this is the way of writing operation, or the first operation, union of sets. Very important. The operation of sets very important. Even for entrance examination, the section seems to be very important. So A union B means either A or B or both. Consider another example. Let X equal to the students Ram, Geeta and Akbar. They are the students in the school hockey team. And another group Y equals the set consisting of Geeta and two more students, Geeta, David and Ashok. Geeta, David and Ashok. These three students be the set of the students who are in the football team. Football team. You are asked to find X union Y and interpret the set. Interpret means you need to define or give the meaning of the X union Y. Okay, listen to the question. Let X equal to the students Ram, Geeta and Akbar. They are the hockey team. And Y equal to the students Geeta, David and Ashok. They are the football team. We are asked to find X union Y. Okay, we can write X union Y. So what we want to do, before doing the union, you need to identify the people or the elements which are common in between those two sets X and Y. Which are the elements common? Geeta is the member who is common in between these two sets. Now I am going to write the X union Y. At first you need to collect all the elements of X, that is Ram, Geeta and Akbar and Then you need to collect the elements of Y, but Geeta already written, so the repeated element being writing only once. So the remaining are David and Ashok. This is A union B. What you can interpret from this set? The interpretation is that this is the set of students who are in the hockey team, or in the football team, or in both the teams. That is the interpretation. They are the students. What is the interpretation? The interpretation means they are the students in either hockey team, or in the football team, or in both the teams. So actually, this is the representation of X union Y. Now we can define the union of two sets are. Let A and B be any two sets. The union of A and B is the set of all those elements which belong to either in A or in B or in both. It is usually represented as A union B. Now I am going to consider another example. Consider the set A equal to the set 2 and 3, and another set B equal to the set 3, 4 and 5. What about A union B? That is non for A union B equals, you need to collect the element which is repeated, that is 3 is the repeated element. So A union B equal to the set of all the elements in A and the elements in B, the common element being taken only once. Now we can see how we can represent this set in a Venn diagram. I told you that in Venn diagram the universal set can be represented by means of a rectangle. You can think this universal set as anything, either as the numbers from natural numbers from 1 to 10, or as the real numbers, whatever it may be, just to represent it as a universal set. And two circles you need to mark for to represent the sets A and B. But try to remember one thing. If there is an element in common in between these two sets, you need to mark like this. One set like this, and another set when drawing you need to make an intersection between these two sets having a common area in between them. I will tell you why we need to make a common area for these two sets. Actually, this is the set A and this is the set B, but I am going to write the common element in between these two sets, that is in between the common portion. 3 is the common element that I am going to write here 3. Now A consists of the element 2 and 3. So you need to mark 2 alone here. 3 inside this portion, and in this set B you need to mark 4 and 5 alone. Now look at this set. This set is actually the set which comprises of 2 and 3, that is set A, and the second circle is the circle which comprises of the element 3, 4 and 5, the common element being writing in between the intersection portion. This is actually the intersection point which consists of the common elements. So this is actually the representation of the above set by means of a Venn diagram. Now we can see what will be this A union B from this shaded region, or from this Venn diagram we can see what is A union B. Look at this one. A union B means that you need to write the elements of A. All the elements of A I need to write. So this much elements, all the elements of A I need to write, and all the elements of B also I need to write. The common element already taken once, so I need to write it again. So this much. So this shaded region represents actually the full shaded region, all the elements of A and then the elements of B. The full shaded region represents the union of these two sets by means of Venn diagram. Now we are going to study some properties of union of sets. Properties of union of sets. Union of sets. Several properties you need to study of this. The first property is that A union B equal to, for any two sets A and B, A union B equals B union A. This property is called as the commutative law. Commutative law of sets, or commutative law of union of sets. A union B equals B union A. This is the first property. Okay, we can check it whether it is true or not. Consider the above set itself. Let A equal to the set 2, 3 and B equal to the set 3, 4, 5. 3, 4, 5. I am going to verify this property. What about A union B? A union B equals, you need to find out the common elements between A and B. The common element between A and B is 3. That you need to write only once. A union B equal to the set which consists of all the elements of A, you need to write it first, 2 and 3. The elements of A, you need to write it first. Then the elements of B without writing the repeated element. This is A union B. Now I am going to write B union A. While writing B union A, you need to write the elements of B at first. The elements of B are 3, 4 and 5. But then writing the element of A in which the common element you must not write. The only element remains, there is 2. Now look at these two sets whether they are equal or not. The first class itself I told you that while writing the sets, the order of the elements is of no importance. Look at 2, 3, 4 and 5. All the elements are same in both the sets irrespective of the order of the elements. So from this you can say that therefore A union B equal to B union A. This is the first property. A union B equals B union A. Come with second property. A union B union C. A union B union C equal to A outside and B union C inside. B union C. You know what this property will be? This property is called as the associative law. Associative law of union of sets. Consider 3 sets. The same as the case of the associative property of the numbers. You know that 1 plus 2 plus 3 equal to 1 plus 2 in one bracket and then 3 outside. Now I am going to consider whether it is true or not through an example. Let A equal to the set 2, 3, B equal to the set 3, 4, 5 and I am going to consider one more set C as the set 1. Okay, at first I am going to find the LHS. I am going to find A union B union C. While writing A union B, you need to remember, you need to write all the elements of A at first. The common element is 3. That you need to note at first, common element 3. So, I am going to write the elements of A at first 2 and 3. Then the elements of B 4 and 5. The common element being taken only once. Now, this you need to take for an union with the element. Now, union C means union 1. Now, you need to take the union of these two sets. Nothing is common in between them. So, we can write as 2, 3, 4, 5. The elements of the first set you need to take. Then when union taking, if any element is repeating, you can take only once. So, this is the answer. This is A union B union C. Now, I am going to find the right set. A union B union C. For A union B union C, at first you write A. What is the set A? The set A is 2, 3. Union. I am going to find B union C. B union C. Nothing is common in between these two sets. So, at first B union C, you need to write the elements of B at first, then the elements of C. Now again I need to take a union of these two sets. If any element is repeating there, you need to mark it. Here 3 is the repeated element that I need to mark. Now I am going to find a union of these two sets which is equal to the first elements 2, 3 and from the second set 3 you can't take, the remaining are 4, 5 and 1. Now you need to check whether these are the two sets obtained for you. Now you need to check whether they are same or not, irrespective of the order. 2 is in both the sets, 3, 4, 5 and 1, they are equal. So from this you can say that therefore A union B union C equals A union B union C. This is the second property. Now come with the third law. So the first law is the commutative property and the second law is the associative property. This is the associative property. Now come with the third law. The third law is law 3. The third law. A union null set. A union null set equal to A. This law is called as the law of identity element. The law of identity element. Which is the identity element here? Can you say A union? You studied in the case of numbers. 1 plus 0 equal to 1. There 0 is the identity element. In the same way, 5 is the identity element. Okay, we can check whether it is true or not. Consider the set A equal to the set 2, 3. And consider the second set is the null set. I am going to find A union null set equals. A is 2, 3. Union null set means a set which does not contain any element. When finding the union of these sets, nothing is common between these two. You need to write the elements of A at first and no elements are there in the second set. So we can't write anything. 2, 3 is the only elements in both the sets. So which is equal to A. From this you can say A union null set equal to A. The three properties I discussed. Now come with property 4. Property 4. Three properties discussed. First property is the commutative property A union B equals B union A. The second property is the associative property. The third property is the existence of the identity element null set. The fourth property that is very important, A union A. A union A equal to A itself. This property is called as the idempotent law. Idempotent, P-O-T-E-N-T, the idempotent law. That is, union with the same set gives that set itself. Okay, consider the set A equal to, the set 2, 3. We can verify this. What about A union A? A union A equals the set 2, 3 that you need to take union with the 2, 3 itself. This is A union A. You know that two sets when taking union, the common elements being repeated only once. Both the elements are common in between these two sets. So the process is that at first you need to write the elements of A, then write the elements of the second set, the common element being repeated only once, that is 2, 3 only, which is equal to the original set A itself. So from this you can say that A union A equal to A means that the union of a set with the same set equal to that set itself. This property is called as the idempotent law. Come with property 5. The fifth property I am going to say property 5. The property 5. Property 5 states that a universal set union A equal to the universal set itself. Don't be confused with these two symbols. Universal set is actually U. The universal set is U actually. The universal set U, that when taking union with A equal to the universal set itself, this property is called the law of universal set. Law of universal set. Universal set union A. Okay, I am going to consider the universal set as the set 1, 2, 3, 4, 5. That is the set of natural numbers up to 5. And I am going to consider a set A as the set 2 allowed, the singleton set. I am going to find universal set union this A equal to. You know that for finding the union of two sets, you need to take the common element set first. The process is that at first you need to write the elements of A 1, 2, 3, 4, 5 and the elements of the second set, the common element being repeated only once. So 1, 2, 3, 4, 5 itself, which is equal to the universal set U itself. So from this you can say that universal set union A equal to universal set, which is the law of universal set. Thus 5 properties based on the union also you need to study. A very important section. What about union? What about the Venn diagram of union? And what are the properties among the union of sets? Union of sets means properties are commutative property, associative property, the property of the identity element 5. A union 5 equal to A. Then the fourth property, the idempotent law, that is union with the same set equal to that set itself, and the universal set law of universal set union equal to the universal set itself. The first operation we studied about the union of sets. Now we are going to study about the second operation, intersection of sets. Let A and B be any two sets. The intersection of A and B is the set of all those elements which belong to both A and B. The elements which are in both A and B, that is the common elements, comes in the intersection of the set. It is usually denoted by the symbol like this. The reverse of union, that is intersection. For example, consider a set A equal to the set 2, 3, 4 and 5. And another set B equals the set 3, 1, 6 and 4. We need to find the intersection of these two sets, A intersection B. The condition is that the set of all those elements, you need to write the collection of all elements which belong to both A and B. Which belong to both A and B means that the common element in between them. At first, identify the common elements. The common elements here are 3 in this set, 3 also in this set. One more common element, 4 and 4. These two common elements, if you collect and write within the set, then it will be the intersection of the sets 3, 4. Why? Because it is the set of all elements which belong to both in A and B. So 3, 4 is both in A and B. That is, the common elements comes in the intersection point. So in the set builder form, A union B can be written as the set of all X that X is an element of A or X is an element of B or both. But in the case of intersection, A intersection B means that the set of all elements X that X is an element of A and X is an element of B. So from this we can say that union, wherever union comes, it means OR, either in A or in B. But if it comes with the intersection, you need to mention it as and means that it is contained in both the sets A and B. Now we are going to define the properties of intersection of sets. You know about the property of union of sets. In the same way, intersection also has some properties I don't wish to discuss by means of examples. The first property you have studied that A union B equals B union A. This is the commutative law in the case of union of sets. In the same way, the first property in the intersection of sets is A intersection B equals B intersection A, which is also the commutative law. This is also the commutative law of intersection. Then, the second property in the union is A union B union C equals A union B union C, the associative law. In the same way, the associative law for intersection of sets is A intersection B intersection C. That must be equal to A outside into or B intersection C. A outside B intersection C. This is the associative law. And the third law in the union is A union null set equal to A. This is the law of the identity element in which null set is the identity element. In the same way, the third law in the case of intersection of sets is A intersection null set that is also equal to A. This is actually the law of identity element which is the null set. And the fourth property here is A union A equal to A, the idempotent law. In the same way, intersection also has the same property, A intersection A equal to A, that is also called as the idempotent law. The idempotent law. So, the first four properties seem to be same, just to change the sign of union with the intersection. But come in the case of the last property, that is the law of universal set. For the fifth property, universal set intersection A is not equal to the universal set, it is A. Why? Because you know that intersection comes with the small set or the elements which are in common. Universal set and A has the common elements as the set A itself. That is, universal set intersection A equal to A. Remember, the law of universal set in the case of union is universal set union A equal to the universal set. Here, the universal set intersection A equal to A itself, the law of universal set in the case of intersection. Now, one more additional property you need to study in this case. The sixth property, A intersection within bracket B union C, that can be written as A intersection B in one bracket, A intersection B union A intersection C, A intersection C, A intersection B union C in one bracket, that can be distributed as A intersection B union A intersection C. Actually, this property is called as the distributive law. The distributive law. So, these are the properties you need to remember in the case of intersection of sets. Now, we can discuss about the Venn diagram also. Consider this set. I am going to draw a Venn diagram corresponding to this set. Universal set, you can think as any set. I am going to represent the sets A and B. I told you that if any element is in common, that you need to mark in the intersection part or the common part. Okay, here I am going to represent two sets in which the first set is the set A, and the second set is the set B. As some elements are in common, I overlapped both these circles. This is the set A and this is the set B. The common elements you need to mark here, this as 3, one element as 3 and the other as 4. Now, the remaining elements are 2 and 5 in the set A, and the set B, they are 1 and 6. Now, you can see that the 3, 4 is the intersection of the set. A intersection B equal to 3, 4. Actually, the intersection of the set comes in this range or in this common area. In this common area, within this common area, you can see the two elements 3 and 4. So, this is actually the intersection of two sets by means of Venn diagram. Now, we can discuss with some problems. First question, find the union of each of the following pairs of sets. Come with the first question. Question A. A equal to the set A, E, I, O, U, and B equal to the set A, C, D. You are asked to find the union of each of these sets. A union B equals, at first you need to identify the common elements in between the sets. I already told you that when two sets are given for you, you need to identify the common element. Which are the common elements here? A is the common element. Then any more? No, here A, C and D, here no elements are in common. So, what about A union B? A union B equal to the set which consists of A, E, I, O, U. That is, at first you need to write the elements of A. Then come with the elements of B, but the repetition of elements is not allowed. So, what you need to do? The C and D alone, you need to write here. C and D alone, you must write here. This is the answer of the first question. Come with the second question. So, A union B consists of the elements A, E, I, O, U, and then C and D. Now, come with the second question. A equal to the set given as 1, 3, and 5. And B the set given as 2, 4, and 6. You are asked to find what about A union B. At first, you need to identify any elements are in common between them. Here, no elements are in common. So, A union B consists of the element 1, 3, 5. The first three elements of the set A you need to write, comma, then you need to write the second element, but as no repetition is here with, you need to write all the elements of the set B. So the answer is 1, 3, 5, 2, 4, 6. Or if you want, you can write as 1, 2, 3, 4, 5. Order is of no importance. Come with the question number C. Question number C seems to be an important question. You are given with the set of all x such that x is a natural number and 1 less than x less than or equal to 5, and B is the set such that x is a natural number and 5 less than x less than or equal to 10. You are asked to find the union of these two sets. Whenever you are given with a set builder form, you need to convert that to A equal to the set. All the natural numbers you need to write, and the condition is that 1 less than x less than 5, but x is a natural number. Natural numbers between 1 and 5 you need to write, but 1 is not included in the set. So the elements are 2, 3, 4 and 5. You need to write that there is a less than or equal to symbol there. Come with the set B. B equals the set of all x that x is a natural number and 5 less than x less than or equal to 10. So the set consists of the elements 5 less than. So now I need to include the element 5, 6, 7, 8, 9 and 10 you need to include as there is a equal to sign. So both must be the set of natural numbers. The first set consists of natural numbers between 1 and 5 including 5, and the second set consists of the natural numbers between 5 and 10 but including 10. So these are the elements 2, 3, 4, 5 and 6, 7, 8, 9, 10. Now you are asked to find the union of these two sets, A union B. A union B equals, at first you need to check anything in common? No. So at first write the elements of A 2, 3, 4, 5 and then the elements of B 6, 7, 8, 9 and 10. So this is the answer of this question. Come with another question which seems to be a very important question. This is actually the 7th question in exercise 1.4 in your textbook. Anyway, that I will discuss. If A equals the set of all x such that x is a natural number, B equals the set of all x such that x is an even natural number, C equals the set of all x such that x is an odd natural number, and D equals the set of all x such that x is a prime number, find. You are given with the 4 sets A, B, C, D. Find the first question A intersection B, then second question A intersection C, third one A intersection D, the fourth one B intersection C, the fifth one B intersection D, and the last one C intersection D. I told you that while you are asked to find the intersection or union or whatever it may be, convert the set to the roster form. That seems to be easy. Okay, we can convert the given set at first. The first set is given to us A equals the set of all x set that x is a natural number. Which are the natural numbers? You know that the natural numbers are 1, 2, 3, 4, 5, etc. are the natural numbers. Infinite set. Then actually we are going to find the intersection of some infinite set. That is why I told you that it seems to be very important. Then come with the second set B. The second set B equals the set of all x set that x is an even natural number. Which are the even natural numbers? 2, 4, 6, 8, 10, etc. are the even natural numbers. That also an infinite set. Come with the set C. C equals the set of all x set that x is an odd natural number. Which are the odd natural numbers? 1, 3, 5, 7, 9, etc. are odd natural numbers. And come with the last set D. D equals the set of all x set that x is a prime number. Which are the prime numbers? The prime one is neither prime nor composite. So the next prime number is 2, 3, 5, 7, 11, etc. are prime numbers. The question seems to be very important as all the given sets are infinite sets. You need to find the intersection of each set. Come with question number 1. What is A intersection B? A intersection B means that the set A is the set 1, 2, 3, 4, 5, etc. that need take intersection with the set 2, 4, 6, 8, etc. Remember, the first set consists of all the natural numbers from 1 to etc. But the second set consists of even natural numbers only. So can I say which will be common? The element 2 is common. In the same way, among the natural numbers, the element 4 will be common. The element 6 will be common. And in general, you can say that you will get the intersection as the common elements as 2, 4, 6, 8, etc. as the common elements, or you can say that this is actually the set B. So in the case of first question, answer A intersection B comes as B itself. Come with the second question. A intersection C. A equal to the set. A intersection C, you need to find. A is the set 1, 2, 3, 4, etc. 1, 2, 3, 4, etc. That you need to take intersection with. What is C? C is the set of odd natural numbers. Odd natural numbers are 1, 3, 5, 7, etc. Now, you need to take the intersection of these two. You know well that 1, 2, 3, etc. all the numbers which when intersecting with the odd natural numbers, the intersection will come as the common elements again as 1, 3, 5, 7, etc. which is the set of odd natural numbers. So, A intersection C equal to C in this case. A intersection C is actually this set is C. Come with question number 3. What is A intersection D? A is the set 1, 2, 3, 4, 5, etc. That you need to take intersection with what is the set D? D is the set 2, 3, 5, 7, 11, etc. Now, can I say what is A intersection D here? This is D, the set D. Can you say what is A intersection D? A intersection D equals here all the natural numbers and D is the set of prime numbers only. So, when taking, you can find that A intersection D equal to the set of prime numbers. What are the common elements there? 2, 3, 5, 7, etc. The common elements comes as 2, 3, 5, 7, etc. itself. 2, 3, 5, 7, etc. will come as the common elements here, which is equal to D. So in this case, A intersection D equal to D itself. Okay, come with the fourth question. Fourth question. What is B intersection C? B intersection C equals the set B is 2, 4, 6, 8, 10, etc. 2, 4, 6, 8, 10, etc. That you need to take intersection with what is C? C is the set 1, 3, 5, 7, 9, etc. Means B is the set of even natural numbers and C is the set of odd natural numbers. Is there any element common in between even natural numbers and odd natural numbers? No, nothing will be common. So it will be the null set. So in this case, B intersection C equal to the null set. Come with question number 5. What is B intersection D? B is the set 2, 4, 6, 8, etc. that you need to take intersection with. D is the set 2, 3, 5, 7, 11, etc. Means that the set of even natural numbers intersecting with the set of prime numbers. Among the prime numbers, you can see that only 2 is the even prime number. So that is the only element common in between these two sets. So B intersection D in this case is B intersection D equals the singleton set 2. And come with the last question, sixth question. C intersection D. C intersection D equals the set of all x that. What is C here? C is the set of all x that x is an odd natural number. Odd natural numbers are 1, 3, 5, 7, etc. that you need to take intersection with. What is D? D is the set 2, 3, 5, 7, etc. So again, what you will get? You will get 1, 3, 5, 7, etc. That is, you will get the set of odd prime numbers. All odd prime numbers will come in this list. All odd prime numbers will come. Look at this. 2 is not a common element between them. 3 is the common element. 5 is a common prime. So all odd prime numbers you can find from these two sets. Try to do yourself, and if in doubt, look at this one. So that I finished this section. Okay, now let me discuss with one more point. Disjoint sets. Disjoint sets. Disjoint set means that sets which has no elements in common are called disjoint sets. No elements will be in common between the sets. No elements in common. For example, consider the set A equal to the set 1, 3, 5, 7, etc. and set B equal to the set 2, 4, 6, 8, etc. Can you say what is A intersection B? A intersection B means that this is 1, 3, 5, 7, etc. are odd numbers. 2, 4, 6, 8, etc. are even numbers. Definite that A intersection B is null set. No elements you can find common in between these two sets. So, if the intersection of two sets will come as a null set, then such sets are called as disjoint sets. Such sets are called disjoint sets. Disjoint set means that two sets which has nothing in common. When drawing the Venn diagram, you can see that the disjoint sets will mark like this. Nothing will be in common between them, A and B. Two sets which seems to be entirely different, that you can't take any intersection between them, or intersection between them is null set. They are called as disjoint sets. So, if you are asked to find whether two sets are disjoint or not, you just need to check this result only, whether A intersection B equal to null set or not. Now, note down this homework question.